Okay, now I have green and orange. So green will be black or minus, orange will be red or positive. Two of these obviously are connected together, the plus of one and the negative of another. They're all cut to the same length. So I'm going to twist a couple together. I'm going to take the two longest, they're about the same, twist them together, and they're going to go on the wire that's remaining here. So we want them to be soldered together, and then I will solder the remaining wire onto that. The remaining coil wire, I should say. Penetrate that good. Very good. The other side, just to be safe. Want a good connection. We don't want these unraveling with time, because these are the battery wires. They're going to be connected and disconnected with time. Okay, now this wire here is going to be wrapped around them and soldered on to them. I'm going to strip down a little bit longer bit of that wire, just so we have a good connection. We want to make sure it's a really good connection, because that is a major wire there. That's your power wire. Okay, now we'll wrap that around here. A couple times around. Solder him in place. Okay. Now we just have the two remaining battery wires. The negative is coming off that other leg off the emitter of the transistor. Okay. So put these aside. I'm probably going to put a wire cap on that. Actually, I'll do that now so I don't forget. Where did I put it? Just to protect that point. So that'll fit in that one. Okay, just to keep that covered. Alright, and then I'll probably put some tape on there to reduce stress on that joint. Okay, now we have the negative of the run battery, which will be our green here, connects to the emitter of our transistor. So the other leg here coming off the transistor, the other leg of this diode. That's why we left it like that, hanging out, so we can connect to it, solder to it. Stay. Okay. that's on there. Now, mostly we're going to refer to the circuitry in the website as we work, so don't pay as much attention and try to concentrate on what I'm doing here, because it's really hard for you to see on here. I hope you can see, but the light isn't so hot, and it's really tiny. I can't even barely see this wire here, for example. Especially can't see it on the camera, so I don't know if you can. So I know it's going to be really hard for you to follow this. And we have one last wire, which goes on the output of the collector, which is the other end of this other diode here. Okay, so I'm going to wrap that in place. I know I'm blocking the camera right now, but I'm going to wrap that in place. Okay, and then I'll solder that wire, and that's our last solder joint. Oh, Felix. Ow, ow. Okay, there's that. Okay, I'm putting on the clips. I've got the run battery is a smaller battery, and the charge battery is a bigger battery, so I got the bigger clamps for that. Okay. It takes a lot less to run the device, and you can use very small batteries to power the device, and then you can charge up larger batteries with it. So Felix gets excited and he puts his claws in my leg, trying to sit up and see what's going on. He still hasn't realized that claws hurt. Those of you who don't know Felix from my normal everyday channel, that's our big cat with big claws. This seems to take solder very easily, this metal. I don't know how that can be. Okay. Alright, there's that. Now, the final one. And then we'll be running here in a couple minutes. I think I'll be able to shut off my soldering iron in a minute. Radio Shack is always a good place to go for stuff like this. Okay, now, just for protection, I'm going to put wire terminals on these, wire nuts. Said that wrong before too, didn't I? Put wire nuts on them, because those are battery connections. Right here, if it'll take it. Okay. Looks like we're good. Alright, so now the next step is to apply power and test the system out. So I'm going to put the coil all back in here, and testing and firing up the Bedini motor will be another separate video, but don't fear, I'm doing it tonight, so it will be coming up next. I don't know if it's going to run or not out of the, first thing. So we've got to experiment, line that up in the middle. We'll have to experiment and see what happens here. I want to make sure that coil's not going to bounce and hit that. I got a little bit of bounce on my coil, so I've got to mess with that as well. I think I'm going to do some zip ties on that wood and put some notches in that to make sure it's going to be okay, because the wood is wobbly and I don't want to use metal screws. So I'm going to take care of that, and we'll be back in a bit. Okay guys, Melanie needs to make some noise, so I have to wrap this up. Alright, we've got two batteries here. Alright, one charged and one not. Okay. The fully charged battery is sitting at 12.97 volts. The not charged battery is at 11.58 volts at this moment. Okay. Now, you can't see my meter, but this just came out in from outdoors, so it's dripping on me. It's full of condensation. Wipe it off my pants. It's just condensation from being out in my electronics lab. I've got to finish this up for the night quickly, otherwise I wouldn't be firing this up with a cold battery. Now, it makes it easier for me because I intentionally left two larger leads, okay, for the battery to be charged, and two smaller leads for the run battery. I've got the coil slipped under here, and I've just got the circuits laying down here, and my variable resistor. So let me get the meter. We're going to use the meter in a minute. We're going to take the negative of the battery to be charged and hook it up here to the negative wire. We're going to take the positive of the battery to be charged, and again, this is much better to use two different size or type clips so you can identify it better and you don't make a mistake. The larger clips on my system are to the battery to be charged. Take the positive of the run battery and put it on here. And again, refer to the diagram for everything, okay? Take the negative of the run battery and put it on here. Oops, I hear a squeak. I heard a squeak. Something's happened. Let me get a different angle here so you can see what's going on better. Alright. Now, I'm going to try to set this up so you can see it as well. Oh, and then we definitely don't want to knock the lead off the battery to be charged at any time, or you could damage the Bedini motor. I don't know if you'll be able to see that very well. Prop up my Leatherman to hold it so you can see it maybe. Okay, I hope that'll show up. Turn it on. Can you see that? Yes, I think you can. Now I'm going to put my wires up under the sleeves of this so that they're jammed in there and make a good electrical connection. Okay, so now my battery is showing 11.35. It's dropping a little bit. Okay, now I'm going to put the negative lead onto the run battery. I hear a squeak when I do that. I don't know if you can hear that, guys. I hear a squeak when I do it, so something's going on. Hear it? There's a squeak. Alright, now, if you don't see any flashes on your lights or anything, then so far so good. Now there's our little green and wheat bulb. That'll be our indicator of how things work. Now everything's wobbly yet. I don't have time to organize that, so I'm going to hold the coil down with my one hand. I'm going to give this a spin and see what happens. You hear that squeal? My resistance is too high. Turn it down. There, see the flashing light? Can you see the light? I can't tell if you see that, guys. It's starting to run up. Can you see the green and wheat bulb here? It's running. I've got it changed. Let me lower the resistance. And the motor is speeding up. Here it go. It's going. It's alive. Look at the voltage, 12.84. I think this battery is too small for this. Oh, I need a bigger battery. Wow, it's flying. All right, now you want to adjust the Bedini motor, the resistor, so that grain and wheat bulb is barely flash or barely lit. And this is going to start speeding up faster and faster. Now my charging is lower. Notice that the battery voltage dropped a tiny bit, but it's going to settle off at a certain point. And that motor is going to adjust and find what's called the sweet spot. It's really spinning now. It's got a nice little hum to it. I think I can let go of the... Yeah, now I don't have to hold the cable. Or the coil. Look at that, guys, it's alive! Alright, keep an eye on this. Can you see it? Oops, too far. You want that just to glow a little bit dimly. So 12.84, 12.85, 12.86, 87. We're going to focus on this section right now. And right there, the little green and wheat light bulb. That's your indicator of how you tune this. I hope that shows up very well here. 12.88. It's still taking off. It's getting higher speed. I'm turning the resistance down. Whoa! The voltage goes up! The motor's picking up speed. It's getting faster and faster. I'm going to turn the resistance up some more. Looks like at a certain point I get more of a charge. There, I get more charge right there. Looks like that's my best spot right there. Look at that charging goes up. And that's what you want to do, is adjust your resistance for the best charge and speed. Now if I change that resistance, my charge will change. It's very sensitive because I have the wrong resistor. See voltage going down. Let's drop the resistance down a tiny bit. Voltage comes back up. And then it went too far. I missed that sweet spot, see? That's what's called a sweet spot. It's hard with this resistor being wrong. But you can play with it and tweak it. You can adjust it. Get your best charging. I'm going to go on Amazon and order the right resistor for my... Oops, there I went too far. Just a tiny, tiny bit. So you can adjust that resistor. There it is, right there. And get your best charging point and speed. There you go, guys. A beautiful sight. Bedini motor is running. Battery is charging. Now this is an analog meter, a digital meter. So the voltage is going to fluctuate a little bit because we're getting high voltage spikes, pulses of electricity into this battery, and the digital meter is doing its best to show you the average of what's going on in here. Now an analog meter will give you a more accurate readout, but you will see a little wiggle in the meter, and that's typical. So we'll let that run a little bit, and we should be charging this battery up. There's the Bedini motor, guys. I hope you all enjoyed the series. I hope it was worth it all for you. That is a beautiful sight when it fires up on the first shot. Sometimes it works right away and sometimes it doesn't. And in the next step, boy, I hope that shows up on the camera, on the video, what I'm seeing on the camera. It's beautiful. On the next video, we'll cover troubleshooting, just for those who maybe don't have success on the first try. There you go, guys. I'm excited. I just keep looking at it. Alright guys, thank you for watching. Troy from the Do-It-Yourself World Electronics. Oops, it dropped down a bit. I'll have to adjust that. Good night, everybody. There's the Bedini motor. Up and running. The final video on how to build a Bedini motor. This is exciting, guys. I hope you all enjoyed the series, and I hope you're as excited as I am. And I hope you all get your motors running. And if not, we'll have the forum up and running for you guys to ask questions. Anybody that's having trouble, do check out the Do-It-Yourself World forum, and I'll put the link on the bottom of the video. Good night, everybody.